Good morning, everyone. Peter Devine, and let's see. Looks like it's what, the 2nd of December, around 9 o'clock in the morning, a little bit before. We've been working with the scale, and I wanted to give you a closer look at it because I think I should have done that a long time ago. You see how this is like a 10-gram scale. The middle one is, I believe, a 500-gram scale, and then in the back here, that represents 100 grams. So we can weigh about something over 600 grams with this scale. And today we're going to weigh some water. Now, what's interesting in the water is that it was the official standard for the gram of the metric system. That is the standard for mass for the metric system. Metric system was established around the time of the French Revolution, I guess 1792, and they had established some, I believe it's 1/10 millionth or 10,000th. I'll check into it, 1/10,000th of the length of the meridian from the North Pole to the South Pole as the standard of length. That's the meter. The centimeter, which is 1/100th of that, is a small thing, maybe about that big. And a cubic centimeter of water at, I guess, just above freezing was the standard of the gram. And then eventually they changed it to like around 4 degrees because it turns out that as we go from 4 degrees to 1 degree, the water actually expands a little bit. But anyway, around the freezing point is going to be good enough for us. And I actually have this beaker of ice water here. That should be close. What I want to do is first see if my scale is zeroed out. Let's see if it is. There's a 0 point, and a little bit above it, looks like. I have to look actually. Just a wee bit above that. So let me try and pull this out a little bit. That is, screw this thing like this. See if that changes it in the way that we want. Not really. Okay, maybe I have to put it in. Oh, exasperating. To put it out, it's. See what happens. Okay, that's very close. So now what we're going to do is we're going to actually weigh a certain amount of water. I have what's called a graduated cylinder. It's graduated. It has markings on it, and that tells us how many milliliters are in this graduated cylinder. A milliliter, remember, is a cubic centimeter. I already told you guys what a meter was. I think it's 1/10,000th of the meridian goes from north to south pole on the globe. Okay, I know they've changed the standards over time. It's no longer what I just said it was, but it's definitely a good benchmark. Now, what I'm going to do is I'm going to pour some water, some ice water in this thing. Maybe I'll, mistake. You don't even have a lot of time. I don't want to, spend a lot of time on each video. I don't want to spend a lot of time on each video because people don't like to watch too long. I'm trying to keep these videos down to about 5 minutes. I think that's a good amount of time. And I'm try and get this. The thing should be dry before you put it in there. There should be no water, but there is just a little bit. So let's go with it for now. I'm going to weigh this thing, and I think it's going to be, let's see, oops, okay, that's 20. Now, we're going to get it until it goes right back up to the middle the way we had it. See, that looks about right. Not too shabby. Oops. I'm going to have to look. Put this keyboard here. Okay, good. All right, so what do we have? We have 4.1 grams. No, 20. 20 is here. 24.1 grams. And I'm going to write that down on a whiteboard back here. Look at it again. 24.1 grams, 24.1 grams. And now I'm going to put, say, 30 milliliters of water in it. It should come out when we weigh it to about 30 grams. Let's see. Oops, that's it. It's close, pretty close. Okay, so I'm going to stick this here. And now I'm going to, now I'm actually going to see where this brings us in additional weight. 30 up. Here's 20 more grams. I'll bring this up 20 more. Well, that's 10, 20. Bring this up about 30. Just see what happens. And there we are. You can see that you just moved the weight 30 more grams, and there we are. Okay, so it looks like it's a little bit less. Let's see if we can move this pointer here. Let's see what. Okay, so 30, about 29.8 actually. 29.8. Why? Because I moved this thing back actually 29.7. 29.7. Okay. So you can see, like I say, we're off 0.3 of a gram, but there are a lot of reasons why we could be off. I want to just say that roughly, let's say it's 29.7, so 0.3 over, say, 30. What does that actually give us? It's 100th. In other words, 0.3 over the entire weight of this is 30. It's within 1%. Now, is that good? It's okay. For our purposes for now, we can live with that. And it does tell us that water is 1 gram per milliliter or 1 gram per cubic centimeter within 1% error. And I'm gonna, like I said, I'm gonna live with that. There are a few bubbles in there, but I think that's just tiny, tiny little bit of error that would introduce. So here we are. Let me just show you that this was 30. because I'm doing stuff. Let's see, it's very hard to see the markings, but I did have it just at 30, the meniscus, which is where the water goes down. The bottom of the meniscus should just touch the point at which you want to measure the water. So we've confirmed at least that ice water is about 1 gram per cubic centimeter with an error of 1%. Thanks for joining us today, and let's do more things with this scale. We're going to do a lot of good things with this interesting scale. Thank you.